This is part 2, heat exchanger. So we want to discuss on heat exchanger type, and this one is according to construction. So previously you have also seen that heat exchanger can be classified according to its transfer process. So for transfer process we have two. So the direct and indirect. So the direct means the fluids are in contact to each other, while for indirect means one fluid is in the tube and it is separated from the another fluid which is in the shell. Okay, so that one you can also watch the previous video. Okay, but for this one, I just want to focus on heat exchanger according to construction because it is more important when we talk about especially the application of heat exchanger. So each application needs special design or custom-made design. Okay, so there are here my classifications. There are 5 classifications. The first two is actually the shell and tube, but the double tube is actually the simpler shell and tube heat exchanger. Then we have plate heat exchanger, spiral, and also fin heat exchanger. So all these have advantages and disadvantages that depends on the process conditions. Okay, so the first one, as I mentioned, is the double pipe heat exchanger. So for the double pipe heat exchanger, actually we call it double pipe because actually there is only one tube, and this one tube is in another tube. Okay, so therefore we call it or one pipe in another pipe. So therefore we call it a double pipe heat exchanger. Okay, it is the simplest one, and the flow can be in parallel or counter current. So for parallel flow, maybe I see, where is my, okay, here, my pen. Okay, so for parallel flow, the direction of the flow for the hot stream and cold stream are same. They are in the same direction. But for the counter current flow, the hot stream and the cold stream are in the opposite direction. So this is coming in, and this is coming in from the cold stream and goes out from this outlet. Okay, so these are the temperature profile. So for the temperature profile, of course, hot stream has the highest temperature for the inlet, same here. Okay, but the inlet, the outlet of hot stream is lower than the outlet. Sorry, the outlet of the hot stream is lower than the inlet. Okay, which is same here. But note that here you have same direction for parallel, and here you have different direction for counter current. So actually what you have to focus is this part and also this part. Okay, because for parallel, you know that this part should be same direction. Okay, should be both inlet, and this part should be both outlet for hot and cold stream. So it is different for counter current. Okay, so you cannot make a circle here because this is in and this is in. So in is actually like this. Okay, for counter current, and out is actually like this. Okay, so this is like the simplest heat exchanger. It is also actually shell and tube heat exchanger, and the more complex one is a large size shell and tube. Okay, so inside is actually more than one tube, and for shell and tube heat exchanger, it is not suitable for aircraft or automatic application because of its large size. Okay, normally it is used in industry instead of for automotive application. Okay, as I mentioned, it's not only one, but it can have more tubes, maybe hundreds. Okay, in the shell. So the size, if you can imagine, is very, very big. Okay, and you can also swim in this shell and tube heat exchanger. All right, the next one, the application for shell and tube heat exchanger. So mostly because it is not used for automotive, it is used for chemical. Okay, it is used for chemical. What is this? Oh, I can use also pen from here. Chemical, petrochemical, and power plant. Okay, because normally shell and tube has very high duty. Okay, and it can withstand high temperature and pressure, and it is can be built from many materials, and it is also already established. The design is already has been established. So shell and tube is one of the most important design of heat exchanger, right? Then we have the shell and tube heat exchanger layout. Okay, so this is like the tubes in the shell. Okay, the shell is the outer part, and the inner part is the tubes, which can be more than one. Okay, which can exist in several hundreds, as shown just now. There is also baffles. So what is the use of the baffles? Actually, the use of the baffles is to support the tube, okay, and also to establish the cross flow. Okay, if you don't have the baffle, the flow of the liquid inside the shell will be just straight. Okay, you don't have to come like this, you don't have to zigzag. Okay, this is like zigzag, right? So without a baffles, the flow inside the shell is straight. So when you have a baffle, actually, you can establish cross flow or zigzag flow, and you can also induce turbulence. Okay, because you have to bend over here and there before you go to the next level. If you don't have it, you don't have restriction, then the fluid will be only straight and laminar. Okay, so if you have turbulence, so you can enhance the convection. So these are the use of baffles. Okay, next, another different kind of heat exchanger. So I will not explain into details. You have fixed tube, you have floating head, you also have U-tube heat exchanger, and you have kettle reboiler. Okay, so normally for kettle reboiler, you use it for distillation column. Okay, by the way, heat exchanger is not a major equipment in the plant. Okay, it is actually just a utility equipment. Okay, so for instance, this kettle reboiler here is used for distillation column. Distillation column is the major equipment, but not the heat exchanger. Okay, what is next? Next is the heat exchanger layout. Okay, so this one is one pass. One pass means for the both shell and tube. So you see that this is the flow for shell. So the fluid will just come from here, and then of course I should draw like this, come from here, then under the baffles, on top of the baffles, again up, down, and out. Okay, so this one is for the flow inside the shell. So it is only in one direction. So that's why we call it one pass. And one pass tube side. That means the inlet for tube is also in one direction. Only one pass. Okay. It goes here and goes to each tubes. Okay. Goes to each tubes and come out at different or another side of the tube. Okay. So these are the so-called one pass tube layout heat exchanger. So we also have okay, what's going on here? This is out of control. Okay, can I go to the next slide? How to go to the next slide? Hello. Iwan. Okay, now, yes. So this is like two pass shell and tubes. So for shell, it is one pass because it come from here, same pattern, only one direction. Okay, but for tube side, okay, the outlet and the inlet is at the same position. That means it goes here, then it comes out here. It makes U-turn. Okay, it makes one turn. So that means this is called two-pass heat exchanger. Okay, so this is the heat exchanger layout. This is the real baffle and the real tube inside the heat exchanger. So can you imagine how many tubes are arranged in the bundle in this heat exchanger? Is of course more than hundreds, right? Okay, I'll skip this one first, and I'll skip also this one. Okay, so beside shell and tube, you also have cross flow heat exchanger. Okay, for mix and unmix, or both with unmix. Okay, so this type of heat exchanger is normally smaller and compact. It is used for gas to gas or gas to liquid, and it is normally used for car radiator and air conditioning. Okay, and what about plate heat exchanger? So plate heat exchanger is actually heat exchanger built up of a thin plate but very big surface area for the to promote the heat transfer. That's why it is made of a very thin plate and very bigger surface area. So this is the size of heat exchanger plate. So you can imagine it is twice the height of the adult here. Okay, so it is very big. And what is the application for heat exchanger of this configuration? So please find it. Okay, so mostly actually, or maybe I just tell you, mostly plate heat exchanger is used for to heat transfer for small temperature difference. Okay, so that means in this case, product that is very sensitive to heat, like drugs or pharmaceutical products or cosmetical products, it is very sensitive, right, to the temperature. So it cannot use big temperature difference. So the plate heat type heat exchanger plays an important role, because here the main reason is because when you have a bigger surface area, the Q is also big, while maintaining low temperature difference, small temperature difference. Okay, so this is another configuration for plate heat exchanger. And for spiral heat exchanger is actually used for palm oil industry. Okay, so it's actually like you have two papers and you roll this together. So this give you the spiral heat exchanger. So if you see here, this is counter current flow, okay, because the cold stream and the hot stream, the direction of these both streams are opposite to each other. Okay, I think we stop here first and we'll continue the part 3 shortly.